All right, guys, I'm Nicolette, and today Brian and I are here with Ben Waters. He is the CEO and co-founder of WiBotic, and they are working on some pretty cool robotic power solutions, and they're working with NASA, and you're doing a lot of fun stuff over there, Ben. So why don't you kick us off and tell us a little bit about yourself, first and foremost, and kind of that journey to WiBotic. How did we get here?
Yeah, first of all, thanks for having me, Nicolette and Brian. Happy to be here. And the WiBotic journey, yes. So WiBotic's mission is to power the world of automation. Businesses have been realizing some of the advantages of automation for many years now, and a lot of them think about how we scale up. How do we go from this proof of concept, few robots, few drones doing some task, to a fleet that is truly, changing the bottom line for our business. And as we've learned, one of the big bottlenecks is the fact that all of these vehicles, robots, drones, material handling machines have batteries, and batteries are a major point of failure. If a battery goes dead on a robot, your very expensive, robot operation is going to be not so helpful. So WiBotic has really tried to focus on solving this power problem for autonomous systems. And the journey started about 6 years ago back at the University of Washington. That's where I got a PhD in electrical engineering. I was researching wireless power technology actually for implanted medical devices, trying to power devices through the body inside that helped people, in this case, with end-stage heart failure. I was working on a device called a ventricular assist device. And as I got closer to graduating and I was thinking about, what to do next, was looking at some jobs and was thinking about being entrepreneurial, and an opportunity arose in robotics. We spoke to some companies while we were still in grad school about this problem of robots docking and charging against physical contacts, and the fact that those contacts can wear out, need to be replaced, be a huge bottleneck, fail unexpectedly. And as they want to grow, they were looking to wireless charging to solve some of those problems around the same time when cell phone wireless charging was becoming mainstream back in 2015, 2016. So flash forward 6 years later, and we've built out a very large ecosystem of products, some of which we're announcing some new ones this week. WiBotic develops hardware to do the actual charging for these devices. We develop software that manages the charging across a big fleet, which is an important piece of the puzzle, because imagine a warehouse where you've got 100 robots and 50 chargers coordinating which charger to go to, how to charge in a way that actually optimizes the system and doesn't necessitate a lot of downtime or waiting in line for charging. Becomes a really interesting problem that we've developed some solutions to help with that. So that's WiBotic in a nutshell.
So okay. First question: what type of wireless charging are we talking about?
Yep. So WiBotic, the wireless charging is a piece of our solution. We actually do desktop-based charging and contact-based charging to some extent nowadays. But the wireless charging itself, which is our core technology in the company, is similar to an inductive system like you see for cell phones, with two major differences. One being the power level. So cell phones typically operate at 5 to 10 watts of power. Mm-hmm. Electric vehicles, on the other hand, are 5 to 10 kilowatts of power. But there's this middle range, which is fairly underserved, and that's where a lot of robots live in terms of how big their batteries are and how much power they need to charge those batteries in a reasonable amount of time. So WiBotic deals with, typically we say, between 100 to 1,000 watts. That's how much power we can transmit wirelessly. And the second big advantage is the flexibility. As you'll probably know from firsthand experience, your cell phone charging pad really has to be very close.
Yeah.
And if you move it a little bit, your phone charging icon, goes away. Mm-hmm. With WiBotic system, we afford tens of centimeters of positional flexibility, which for a robot trying to dock against something on a wall with a LiDAR where the whole wall basically looks the same from the robot's perspective, having this flexibility either in the distance between the antennas or, the lateral offset between the antennas is really key. And it goes without saying for a drone too, right? Drones landing in the wind, good luck being accurate to a millimeter every single time. But that 10 centimeter-ish range makes a big difference for those types of things. So those are the two big differences between the way we do wireless charging.
Right. So you mentioned antennas. Is it like, when it's a plate, like if we talk about the cell phone charger, so it's a plate that the robot or the vehicle is going to sit on, or can it sit above it slightly?
Yep. Yeah. So typically our system has two components on the docking station side and two components that get integrated with the robot. Mm-hmm. The antennas are two of those components. So we have a transmitter antenna and a receiver antenna. And those are wound inductors, basically. Mm-hmm. And when they get close to one another, that's where the wireless power transfer takes place. So typically for a drone application, the transmit antenna would be embedded, beneath the surface of a drone charging pad. And the receiver antenna might be extended below the main compartment of the drone, or it might be mounted on one of the landing gears of the drone. And then when the drone lands, they get close enough for power transfer.
Right.
Similarly, for a robot, the receiver antenna might be integrated on the front of the robot or just behind the plastic shell of the robot. And it can drive up to the wall. So there's a lot of different ways that our system can be implemented. Really just depends on kind of where there's space on the vehicle, how it makes sense for that particular vehicle to think about docking. But at the end of the day, it can be done in a number of ways.
Mm-hmm. Brian, are you going to ask that question that you asked?
So we talked about this with Jim Witham, who's
from GaN Systems.
President of GaN, yeah. And we think about drone delivery, right? So when you have drone delivery, you don't really necessarily want to dock your drone somewhere. Is it that it's going to be hovering while charging? Do you know what I mean? So whatever, it's on top of, I'm just making this up, but you have an electric pole. You have your antenna there, because you already have the power source, and you're hovering, versus actually stopping. Do you see that as being part of some of this, even maybe with vehicles, where they get charged while they're sort of semi in motion? I want to say, I don't want to say really in motion.
Yeah, it's a good question, and it's one that we've thought about a lot. I think the science aspect of it is super cool and helpful. The practicality aspect of it is where it starts to get tricky. And I'll just give an example of that. So when a drone is operating, right, it's consuming a lot of power relative to the weight of its vehicle, of itself. A drone needs to use a lot of energy to stay flying, especially if it's got a payload like a package on it.
Right.
And so let's just say, for example, a small to medium-sized drone, while it's flying, might be consuming 200 watts, just a random number, probably accurate for a drone of a certain size. So now if you're thinking about charging that vehicle while it's flying, not only do you have to send enough power to cover the power that it needs to fly, but then you also need to send power that would charge the battery. Compare that to an example where a drone lands. Now it doesn't have that extra overhead of 200 watts of power that you need to deliver to it. All the energy that you deliver to it can just go to the battery. So that gets really tricky as you think about bigger and bigger vehicles, because now you're having to send a lot more power. Now that means your charging pad is going to need a bigger power source itself. And if these things are remotely deployed, that gets tricky. So there's a lot of little practical power challenges related to that. And I say that not to say that there's not a use case where it absolutely makes sense. Just most of the applications that we've seen for beyond visual line of sight, autonomous drone charging are a scenario in which a drone lands, charges, and then continues on. For drone delivery, for example, that could still be very useful, right? Like if a drone never had the ability to charge while it's out delivering a package, it's only going to be able to go half as far as its battery can allow, which might only be a couple miles from the site where it took off. But if you have these pads where it can land, charge, keep going just for the sake of charging, now you can deliver packages much farther away. So we typically think about it as a land and charge, just so that you're increasing efficiencies. I really like how Elon Musk thinks about charging for vehicles. Anything even remotely less efficient times millions of cars and the amount of power that they consume. I mean, are we really doing our world a service for energy efficiency?
Right.
So that's the one thing to think about.
Yeah, no, and you're right, because at that point, you're dedicating the entire charging to the drone, where if it's hovering, you're spending a lot of energy for it to just hover, where it's not really that efficient. So here's my next question. You also mentioned, right?
I told you he was going to get excited.
Yeah, I'll come to the question. So you also mentioned them having, there's multiple chargers. Say you're in a warehouse situation. So you have 100, autonomous vehicles, right? Some are charging, some are working, some are charging, some are working. So how are you coordinating? Like, how is the AI working, right? Are you guys building the AI that helps them coordinate? Like, okay, time for me to charge. They know they're getting low. Time for me to charge. How do I find a dock that's open? And one that's efficient for it, right? Because I'm assuming there's, depending if you have various different types of robots at, powering up at different levels or different battery capacities, you're going to have multiple types of chargers, I would assume, but maybe not, or some that are deploying at different wattage.
Yeah. Great question. And here's a trend that we typically see. So, we'll get a call from a company who says, we've got, 3 different types of robots that they're using, that we're using. We have a floor cleaning robot, we have a material handling robot, and then we have a robot that operates, in the back room and moves things around just in the back room. And they all are built by different companies, and they all have their own charging station. And this is a huge pain for our business, because if a worker happens to move one of those charging stations, then we have to go figure out which charging station it was, log in, reposition the waypoint for where that charging station was. And this is not going to work when we have thousands of these things. So we get into these types of discussions a lot. And really, the companies, I mean, if you're an end user of a warehouse system, you probably don't care so much about how the charging is getting done, so long as it's just getting done. But you probably care about the fact that you don't want to be in a position where all of a sudden you might have all your robots with dead batteries and they all need to charge at the same time. So how do you avoid this type of thing gets really hard, because you don't have control over it necessarily. Your robots might operate one way one day and a different way another day, and eventually the perfect storm comes together where they all have dead batteries, and in the middle of the work shift, there's nothing that you can use. So the way that we think about it is in 2 ways. One, our systems are interoperable, meaning you could have a floor cleaning robot and a material handling robot, potentially with totally different batteries. But if equipped with a WiBotic onboard charger, those robots can go to the same charging station. The charging functionality of our system is battery agnostic. We can charge any type of battery, and the transmitter, when any robot docks to the transmitter, we just power it up. So from a hardware perspective, we've architected the system in a way that is amenable to that type of operation. And from a software perspective, if you just think of one-to-one, like one robot and one charger, we're aware when there's a robot in range of that one charger. And we're also aware when that charger is available. So we can extend some basic data points about charger availability and charger location to the robot itself. We have a communication layer that allows the robot to talk to our charging infrastructure. So if you take that and multiply it by hundreds or thousands of robots, there start to become some really interesting trends. And we pay attention to those trends. We store log files of every single charge cycle and track the overall fleet uptime just from a pure charging perspective, like number of minutes robot spends charging divided by number of minutes robot spends operating, and how does that trend over time? And it's very spiky, as you might imagine. So we sort of have a database. We leverage that information. We also don't say that there's one way to do it for every single application. It really does depend on the specific warehouse and how utilized the robots are and how big the battery on those robots is. So my point being, there's a lot of interesting data points that exist to figure out how to optimize that logistics for a given setup. And we try to be the company to help folks do that.
So do most companies then actually go and create like a charging room or a charging area? So it's like, here's the one area, here's the one wall, because, I can imagine, like, say, for instance, you're using drones and maybe it's, it's a plate, so it's landing on it, and some robots, they're rolling up on it. But say, for instance, you have something like a Boston Dynamics, maybe the charging is on the back end of it and it can't really get flat to the ground. So when you work with them, they're creating charging areas where some's in the wall, some may be in the wall, some may be on the ground, some may be even coming down from above, depending on the types of robots they're currently using?
Yep. Yeah, for sure. Totally depends on both the physical constraints that the robot might have. Surprise, charging usually gets left towards the end of development effort to get integrated and tested and optimized.
Right, to figure out where they're charging.
Yep.
Yeah.
So we're always working around, where should it go, given the fact that this thing's basically already been built. And
well, how does that? Why does that happen? Why is it such an afterthought?
That's a good question too. I think that oftentimes robotics companies have a lot of work to do to just get the things to navigate correctly. And then once they get the basic movement and navigation down, they're quickly sidetracked into, okay, how do we build 5 of these or 10 of these, because we've got customers who want to test them out. And then they finally figure out how to build a handful of them and they get them deployed. And then the customers, find issues, or they say, hey, it's super annoying to have to plug this thing in every day. Can we get charging on this? So I think it's just simply that there's always a high priority in robotics. There's always a bug to fix. There's always a hardware problem to solve. And adding new features is just time consuming and tricky. And, that's an area where we've tried to say, look, it's nice to think about charging early because there's really some advantages you can think about. Brian, to your question, there's a huge advantage, we think, to thinking about putting charging in a position that gives you different options. Like in a warehouse, if it's on the bottom, for example, then you can create kind of a runway in a primary aisle where the robots tend to operate, where you can be charging them while they're moving. But if you put it on the side, that's going to be a lot harder to do, So like there's little things like that I think can make a big difference. But oftentimes, to your question, Nicolette, it just is always sort of the next priority. Right. It's never the top priority until it's too late.
Do you think a lot of, even when they're designing them, right, especially the smaller robots, they're just going to plug it into the wall? Like, that's like, because you see so many of these things, they're plates, you're plugging them in, versus really having, wireless charging or charging built into your structure, like you're saying, like that runway, it's just going to get plugged into the wall. And I think sometimes that's where probably they go wrong with designing them, not thinking about like you're saying, their real application. Like if they're moving down this aisle, that's where they should be charging, not plugged into a wall in the corner of the room or a corner of the warehouse.
Right. Exactly. Yeah. I think the most successful fleets, if you're just looking at like an uptime perspective, are the ones that do think about optimizing this. And those tend to be the larger ones, right? Because at bigger scales, these problems just really get amplified. Imagine if all of a sudden you had 500 robots in 200 different locations around the world, all of which needed a new battery. Like, how is a robot company going to solve that problem? Are you going to just say to all those customers, okay, just ship all the robots back to our warehouse and we'll swap the battery? Like, is it even serviceable? Is it even possible to send a tech out there and open it up and swap a new battery in? And I mean, batteries are going to need to be replaced eventually. It might be 1 year, it might be 3 years, but that problem at a big scale is hugely costly, both from just the sheer material costs of buying these batteries, shipping things around, and the downtime that your customer is going to naturally experience, when these robots are getting serviced. So how can you avoid that? Like, maybe some companies want it to be done all at once. Maybe some companies want every week we'll be approaching the time at which this battery is going to need a new one, but we just will have to deal with it, one at a time. Like, those types of things are where we see a lot of success when companies really think about how to solve those problems, early. When you're chasing your tail, it gets really expensive and it gets really tricky long term.
Now, we see, we're talking a lot about warehousing and things like that and industrial stuff. Do you see this eventually rolling over into homes, right? Because as people are incorporating more and more robotic devices into their homes, are we going to have that same issue and have to work on technology for the home that works the same way?
Yeah, it's one question I've enjoyed thinking about, and I don't have a perfect answer to it, but it is, how many in, let's say, 10 years, how many battery-powered devices do you think you're going to have in your home? Like today, I've got my phone, headphones, watch, battery packs to charge those that I got to charge those. I don't have an EV yet, but, maybe an EV one day. 5 or 10 or so devices, and it's kind of a pain. There's always a day where you're like, can't use my headphones because I forgot to charge them, or something. So like in the future, what's it going to be? Is it going to stay the same? In which case, maybe people can just kind of deal with managing it, or is it going to become like 100? In which case, we're all doomed unless there's really a great solution for charging these things without us having to plug them in all the time. Yeah. So I think as you just think about those scenarios, I mean, it's hard to know. I think about, like, there needs to be some way to just see all the data about charging of all your devices. We found that to be a helpful thing for the robot environment, where it's one interface where you see all the batteries and all the chargers, and you don't have to look anywhere else. You don't have to go find where the thing is. You just know it.
Oh, you know how many times Roomba has crapped out underneath my couch? You know what I mean? It just sends this little warning signal. I'm like, where are you? Where'd you go? So
I have a question. So how you were talking about, battery agnostic. So I have a question because I really don't know the answer to it. If I have my smartphone and I have an electric vehicle, right? You can't charge those on the same battery, right? Even if, can you?
Yeah, the way battery charging, works in a nutshell is that different battery types, different battery chemistries, different battery voltages, are all made up of just how many cells are in series and parallel inside of a big pack. And so, for example, if you've got a 4-cell lithium ion battery, a common battery found on a drone, that battery typically will want to be charged up to about 4.2 volts per cell. So 4.2 times 4 would be the voltage that pack wants to be charged up to. So you would have to have a charger for that battery that's capable of putting out that proper voltage and regulating the current that goes into it, so that you're not going to, overpower or overcharge that particular battery. The challenge with having chargers be battery agnostic is that you would have to have that same charger be able to accommodate a 16-cell battery that might charge up to almost 60 volts. And that's a wide range for electronics. Electronics typically you pick one voltage and you design it for that, because then things are simple. You don't need a lot of programmable parts or parts that are over-spec'd. But that was kind of how we went into it from day one. So to your original question, can a cell phone charger charge a car? Well,
or vice versa. Can a car charge a cell phone?
Right.
Maybe.
Yeah. So, the voltage of a cell phone batteries typically are just one cell. So like, charging up to 4.2 volts or something like that is what you need. Whereas your car is much higher voltage. So, so certainly you could, and certainly there's a lot of, DC to DC conversions that take place already in our cars to power from a battery pack, all of the stuff. But generally, that's what makes it challenging. And that's often why battery chargers will just have like a narrow set of batteries that they're compatible with. I mean, even ours, we could not make our charger output 400 volts because it wasn't designed for that. And maybe, you could stack a whole bunch of them up in series, but still that becomes kind of a different product altogether. So
I have this thought of how
it would charge it in about 3 years for you, Nicolette.
Right.
Okay, because I have this thought that when you're talking about consumer and how many of our devices would need to be charged, right? So I'm thinking like, all right, you got even maybe your coffee maker and all of your things just are wirelessly charged, and maybe you can build in those charging mats into your home, right? And then you just kind of throw your device like on the counter, it just charges like all the time. You know what I mean? I just have this really out there thought, but I wasn't sure if that would even be possible.
I've actually seen desks. There are desks that actually have
but think about it. But to Ben's point then, right, you needed to charge your coffee maker, your cell phone, and your whatever else is on your counter at the same time.
Right. Well, that's where I was going with, like, you have those mats, you have that runway like in a warehouse. Right. Do you eventually have that in your home, right, where all your Roomba's running off of it, your little mopping version of Roomba's running off of it, like all the things that are running around your house, are those charging while they're going? Do we see that rolling out into the home? Like you're saying, just a giant mat where you just run over it,
Yeah. Yeah. And there are definitely companies out there working on different types of wireless charging where your phone would just be charging in your pocket magically. Right. There's a lot of technology behind that. And typically, I think there will always be a constraint on how much power you can send with charging technology that operates like that because of the human safety element. Right. Charging things is a lot different than getting things Wi-Fi in terms of how much power they need.
Right. So it's not going to be like where they could charge the earth up and you could plug your light bulb into it like we've seen with
never say never. It's been done, a long time ago. And but yeah, I think the reality of what's coming, in the immediate future is tables with integrated, charging for specific types of appliances. There is a wireless charging standard being developed for kitchen appliances.
So speaking about that, that was going to be our next question. Are you going to see more standards now? Within this, as more and more things, to Nicolette's point, like now you may have your coffee pots, wirelessly charged or whatever. Or are we going to see more standards in other appliances? Like we see some of it with like phones and things like that, but are we going to start seeing more standards in other electronics?
Yeah, I think definitely. I think when the wireless charging standards of the world started in the cell phone space, makes a lot of sense, right? Phone manufacturers need to be able to put a chip in the phone, and then third-party vendors need to be able to sell infrastructure that can charge it. It's happening with cars now. It's still ongoing, but cars will have wireless charging systems integrated with EVs, and then it'll be nice to be able to go park it anywhere. Right. We already deal with this world of like there's a million different plug-in chargers, and some work with your car and some don't. And I think there's efforts to avoid that in the EV world moving forward. There's a standard I mentioned on kitchen appliance being developed. There's one on e-bikes. So the tricky part is that because of those things we were talking about before, Nicolette, with like different voltages and different power levels, the standards sometimes have to cater to that. They try to be as agnostic and device and industry agnostic as possible, but at the end of the day, I think there are things that force you to have some interoperability. So the other thing I think that's really interesting in standards that WiBotic's been a part of is if you look at FAA stuff for drones, the FAA is obviously doing a lot of great work on enhancing the ability for drones to be flown more autonomously. But there's a lot of safety things that you have to keep in mind. One of them is, how do you deal with the standards around a battery-powered UAV? The commercial aviation industry with jet-fueled planes, has had a lot of time to optimize these rules. But basically, it says, if you know that your plane needs to travel this far and it's got this much weight on it, multiply that number by about 20%, and that's how much fuel you have to put in your plane. And that amount of time the plane will be able to fly with that same amount of fuel is pretty much always going to be the same. That's not the case with a battery, right? If a battery gets installed on a drone on day one and needs to fly this far, it probably could do it. But as we know with our phones, your phone starts to only last for a few hours a day because the battery gets older. So like, how do you deal with that? What rules is the FAA going to have to say as far as like, okay, when your battery gets to be, 400 cycles in, then you can't fly it for this application. It's a much harder problem. So we're part of a panel actually that's kind of thinking about that, like how much testing needs to go into a battery that will be approved for those heavy industry applications and things. So totally, not just in the wireless charging world, but in power in general, I think we're going to see a lot more standards.
No, so you mentioned the cycles, right? The amount of cycles that your battery goes through. But when we look at like smartphones, right, the way they produce it back out is based on the amount of life your battery has, right? So what's the difference between the cycles they're running through and the life that's left in a battery? Yeah,
typically I've been fighting this on my computer. So on day one, let's just say your battery has 10,000 milliamp hours of capacity. So that means if you had your laptop fully charged and your laptop consumed exactly 1 amp of current continuously, 10 amp hours divided by 1 amp leaves you with roughly 10 hours of runtime. Now, that's typically not the way things work. Typically, power is always changing a little bit, but that's the way to kind of think about how long a battery would last given its capacity on day one of about 10 amp hours, 10,000 milliamp hours. So what happens as the battery gets older and as it gets aged and as you're charging it up, it's not able to store that full 10 amp hours of energy. Maybe it'll get to 9.5 amp hours. And my laptop keeps beeping at me now because it's like, your battery needs to be serviced because your capacity is now at 8 amp hours. So it's come down, a little bit. So now, even if I charge my laptop up all the way, and if I have that 1 amp that my laptop's consuming, it'll only last for 8 hours now. And it just will steadily get worse. And how batteries decay and how they lose that over time capacity is special and unique to each battery and how it's used. But that's the challenge. And typically that's what happens is you eat into how much total capacity your battery has over time.
All right. Well, we didn't get to many of my questions today.
Sorry. Do you have any questions?
That's okay, because I think we had a really, really good discussion nonetheless. So it was it makes it more exciting that way, right? But then please, anything you want to leave us with, anything you want to tell us about, anything that you're working on before we let you go?
Yeah, no, I think we touched on a lot of cool topics. The how many devices are going to be in your home questions one that we think about a lot, just for fun, but also for future business ideas. And yeah, we believe that power and batteries are going to kind of be the new really important cool thing. I mean, there's been lidars, and then there's been the vehicles themselves, and it all kind of, everyone's getting used to seeing these types of things now. But I think the next wave of how do we actually power all this stuff at a big scale, buildings that have thought about this ahead of time and integrate charging infrastructure into a building, all the standardization that naturally will come with these things. Space, we didn't get a chance to talk too much about space, but imagine, at least in these areas on Earth where a person can go fix it, in space, once it goes, it's gone. And however you've decided that it should be serviceable or work, that's what it's going to be. So I think space will force people to think a lot more about these design constraints early, and may even be a example for applications here on Earth in terms of how to do things right. So I really appreciate the time and the opportunity, and hope we can chat again.
Yeah, we're definitely chatting again on space.
Yeah, next time let's do a whole. That's really where I was going today, but Brian, we took it to a whole new level.
All right, so
okay.
part two.
We'll
Make
do
sure
a part
to
two
subscribe for part 2 with Ben.
Yeah. Well, Ben, thank you so much. Can you let everybody know where they can check out what you guys are working on?
Yeah, for sure. We are at www.wibotic.com. We post a lot of updates on LinkedIn, so please follow us on LinkedIn. And if you just so happen to be in Atlanta, we are at the AUVSI Exponential Trade Show this week. And on our website, you can see all the trade shows that we're signed up for this year. Trade show season is back, and we are excited to be exhibiting at a few of them second half of this year.
Awesome. Thanks again, Ben.
Yeah, and you definitely got to come back, Ben. We got to talk about space.
Sounds good.